Hey guys, it's Kerry, and in this video we're going to be doing the answer key for homework number 4 from Unit 6. So in the grid below, draw a function that has the following properties. A vertical asymptote at x equals 3. So we'll go to 3 on the x-axis. We'll draw our vertical asymptote. It's going to have 2 horizontal asymptotes, one at y equals -2. So we go on the y-axis to -2, horizontal asymptote, and the other at y equals 5. All right, so now that we've got our asymptotes set up, we can draw our function in, and there's a number of correct possible answers, but probably even more incorrect answers. So because we're just given the asymptotes, we don't know the end behavior on either side. So maybe I'll make this the end behavior on the left side, and this the end behavior on the right side. So I'm going to sketch in green, I guess, the function. So it'll be something like a hyperbola. So it's going to get close to this line over here. It's going to approach that. Then once it comes to the vertical asymptote, it has to curl away and get really close to becoming vertical. Now over here, it's going to start off almost vertical at the vertical asymptote, and it's going to curl down towards the horizontal asymptote, getting flatter and flatter. So this is one possible solution. It's not the only possible solution, but I'll leave it at that. All right, so now we jump into the algebra problems that are more familiar from the most recent lesson. So let f of x equal that. We want to know for what value of x does f of x equal 4, so we'll set the function equal to 4. We multiply by x plus 3 on both sides to cancel the division by x plus 3. That gives us x minus 3 equals 4x plus 12. Getting all the x's to one side, we'll subtract x here. That leaves us with -3 equals 3x plus 12, minus 12 on both sides. 3x is equal to -15. Divide by 3 on both sides. X is equal to -5. For problem number 3, let f of x equal this, and g of x is equal to that. For what value of x does f of x equal g of x? So we want our two functions to be equal to each other. So let's make our two functions equal to each other. Sorry, I'm rushing a little bit here, but in order to get rid of division by x plus 2, you need to do the inverse operation times x plus 2 on both sides. Multiplication by x plus 2 cancels out the division, leaving you with 2x minus 1 equals. And now we've got a massive distribution on the right-hand side, so we do x times x squared. X times 2, 2x, -2 times x, -2x, and -2 times 2, -4. Combining like terms, 2x minus 2x cancels out. So we get 2x minus 1 equals x squared minus 4. And we're so close to having the perfect sum and product format. Let's move everything to the same side of the equation, get it equal to 0, and we get x squared minus 2x. -4 plus 1 is -3 equals 0. Now we use sum and product factoring to solve this. X minus 3 times x plus 1. X is equal to 3, and x is equal to -1. All right, problem number 4 is probably the craziest looking problem on this homework set, but as long as we're careful understanding it, I think it's going to be pretty similar to the ones we've already beat. So we got f of x is equal to 6x minus 3 to the -1st power. We want to know for what value of x does f of x equal 3. So we'll set our function equal to 3. All right, so this is where things look a little crazy. We have to remember we've got this negative exponent. And we haven't seen a lot of negative exponents where it's applied to a binomial like this, but a negative exponent always means to flip this into the other part of the fraction. So because 6 is not to a power, 6 stays on top. The x minus 3 gets flipped into the denominator. So we end up with x minus 3 to the 1st in the denominator. But the 1st power just means that you have x minus 3 one time, x minus 3 itself. So you get this. Finally, to solve for x from here, you're going to use some ideas similar to the one above. So I'm actually going to let you finish this one on your own. That's a question mark for a mystery answer. All right, now we jump into the back of the problem set, and the back of this problem set incorporates problems where we've got 3 fractions. So I'm going to leave 5 for you to figure out because I want to show you problems 6 and 7 as they're the more difficult ones. So we'll have x over 12 plus 1 over x equals 2 over 3. The ideas we use to solve this problem can be used to solve problem 5. So we want to add these two fractions. In order to add two fractions, we need a common denominator. So I'm going to try to convert these to 12x. So I'll do times x on top and bottom. I'll try to convert this one to 12x. I'll do times 12 on top and bottom. That gives us x times x squared, over x times 12, 12x, 1 times 12, 12, x times 12, 12x. This all equals 2 over 3. Now that we have a common denominator here, we can add our fractions to make one fraction. We get x squared plus 12 over 12x is equal to 2/3. Now, this is a little bit of an unusual step, but it's the one that we talked about in class, helping us out in tomorrow's lesson. So it'll be nice, since we want to make these two fractions equal, if we can start off by making the denominators equal. So because we have 12x here and 3 here, all we have to do to make them the same is take the fraction on the right and multiply by 4x on top and bottom. This gives us x squared plus 12 over 12x, and that on the right-hand side gives us 8x over 12x. Because we want these fractions to be equal, and the denominators are already equal, we're done with that part of the fraction. We can focus now on making the numerators equivalent. X squared plus 12 is equal to 8x. And this is great because it's a much easier equation than the one we started with. We're down to no fractions after starting with 3 fractions. And it's in a classic form almost. It's almost exactly the sum and product form. So let's subtract 8x on both sides to set it equal to 0. Now we get x squared. Always make sure the x term is in the middle, just like I placed it. Minus 8x plus 12 equals 0. Now we'll use sum and product. X times x is x squared. Two things that add to negative 8 multiply to 12 are negative 6 and negative 2. That gives us x equals 6 and x equals 2. All right, so down to the last question here, and this is one of those crazy ones where we're working with all letters. So solve the following equation for a in terms of b and c. So we've got 1 over a plus 1 over b equals 1 over c. So even though it's all letters, the structure matches the problem that we just solved. So we're going to solve the solution using the exact same algorithm. Let's start. In order to add the fractions together, we need to have a common denominator. So we'll do times b here, times a here. That gives us b over ab plus a over ab equals 1 over c. We get b plus a over ab equals 1 over c. Now, we want to make these fractions equal, and I'd like to use that same trick about finding an equivalent denominator so that we can focus on the numerator. So in order to get an equivalent denominator here, let's try to get all the letters in all the denominators. So I'll do times c here, times ab here, and that will give us the same denominator for both of these. So we'll have c times b and c times a. That's bc plus ac equals, over ABC, putting it in alphabetical order, ABC equals AB over ABC again, putting it in alphabetical order here. Now, because we want these to be equal and the denominators are already equal, we can focus on just the numerators. So we want BC plus AC equal to AB. So this equation, just like in the problem above, once we've eliminated the denominators, already has a much better outlook than the original problem since there are no fractions. Now, to solve this one, it's a little tricky. We have to realize that we're solving for a, but we have a on both sides of the equation. So we need to move this a term to the same side as the other a term, and we get BC is equal to AB minus AC. Finally, with two separate a's, it'd be impossible to solve. So what we're going to do is we're going to use GCF factoring to factor out the a, and we'll end up with a times b gives us ab, and a times negative c gives us negative ac. This is all equal to bc. Now, with just this one a here, to isolate it, the opposite of times b minus c would be divided by b minus c on both sides. So we end up with A equals BC over B minus C.